periodic table has various elements, about 100 elements there. Most of them are solids, some liquids, some gases. So for solids, this material this instrument can deposit a very thin film of that solid. So if you want, for example, a very thin film of gold, which is difficult, you would take a lump of gold or a disc of gold, place it in this instrument, and the laser would come in and deposit laser energy, photon energy, onto the gold target, and the energy is absorbed so quickly by the gold or the material that it explodes, ejects. Right? When it ejects, it leaves the surface at very high speeds and very high energy and very high temperature. And in those cases, the material is almost in its elemental form. Sometimes it is in atoms, sometimes electrons, positive charges, negative charges, basically like a plasma. So when you see a laser hit a sample, and you look at the glow that is produced, that is basically a very weak plasma that is produced by the laser. Right? So the laser will come in, it's a pulse laser, so you can imagine your laser pointer. Your laser pointer is a continuous wave laser pointer. Let's see, where's my laser pointer? It's not sure. Oh, where is it? It's wrong. Yeah, I got it. Right, so this is a continuous wave solid state laser. So a pulse laser is doing this, right, at a very controlled frequency. You can control the frequency at which this is pulsed. So also being pulsed, it means that a lot of energy is packed in one pulse, a lot of energy. So 500 millijoules in terms of in chemistry or in cooking is very little. But this energy is a compact energy, 500 millijoules, that can be delivered in 10 to the minus 9 seconds, in a very short time. So in that very short time, the material absorbs that energy. And what happens is that the energy is so much in such a short period, the bonds that hold the material together, the chemical bonds, right, metallic bonds, chemical bonds, covalent bonds, depending on the material you're plating, is broken. And when they are broken, this material is free to leave. And when they leave, they move up perpendicular to the surface. And so if we place something in the way of it, we can coat that material onto that. That's what happens. So in this way, in this experiment, in whatever we want to coat, we can control the temperature. You can control the temperature from room temperature right up to 850 degrees Celsius. Because what happens if you want to create a thin film from some material